Okay, welcome to the next lecture, and we were discussing one of the most important topic in this AC machine course, that is the production of rotating magnetic field. Okay. And in our last class I told you that there are three phases R, Y, B, and you can connect them in star or also by delta, but star connection we have taken, and if you energize the R, Y, B windings of the machine from a balanced three phase supply whose R, Y, B are connected respectively to R, Y, B of the machines. Then what happens? There will be a rotating magnetic field, and this rotating magnetic field, the resultant field at any point was written something like this: cosine omega t minus theta. It could be also plus. We will examine those things in detail. The equation cosine omega t minus theta, if you take minus sign, it indicates a field moving in the forward direction of theta, and if you take plus sign, it indicates a field moving from in the negative direction of theta. So, this is a standard equation for a travelling field, but in any case we will examine that in great detail, and also we will try to show you that from another point of view how this rotating magnetic field really moves as time passes. So, let us start. So, we are discussing actually rotating magnetic field, okay? Rotating magnetic field and its various aspects. So, this is the thing. So, after doing all these windings, let me draw that this is my R phase winding, which I drew vertically, that date does not matter. So, so suppose this is your R winding, R phase, and this is your Y phase winding, Y 1, Y 2, and this is your B phase winding. And I will assume that the terminal marked with 1 and 2, if current enters through 1, it will produce a field along this direction, the field is produced. Okay. That is, if current enters through R 1, field will be produced along this. This is and if current enters through Y 1, field will be produced away from the center, and so on. Now, so this is R 1, R 2, Y 1, Y 2 and B 1, B 2, and they are separated by 120 degree angle, and suppose if they are connected in star, this is R 2, Y 2, B 2 shorted, and these terminals I will connect it to a three phase supply, balanced three phase supply with phase sequence R, Y and B. This is supply, three phase supply. Now, these currents all will be time varying current, I R, I Y and I B. Okay. That is the idea. Now, first thing is, suppose I start measuring theta from the axis of R 1, R 2. I will measure the value of theta, and theta measured positive is in this direction, theta. And suppose at a point P, I want to find out the resultant field because of the R phase field, Y phase field and B phase field. As you can see, the field at point P, this field is B max at any instant t, B max cosine omega t and cosine theta, assuming that I r is equal to I max cosine omega t. Similarly, I y is I max cosine omega t minus 120 degree and I b is I max cosine omega t plus 120 degree. So, these three balanced currents are passed and this is theta equal to 0, axis of B phase, and theta I will measure in this direction. And then I want to find out the resultant field at point P. So, resultant field at point P will be the component of this field here along this at point P because of this. So, it will I think I should not write cos theta here, it is B max cosine omega t, its cos component. So, it will be B max cosine omega t and then cos theta plus, because of Y phase, this angle is 120 degree electrical. So, this will be B max, current is cosine omega t minus 120, but this angle you note, it is cosine theta plus 120. And finally, the B axis, for B axis it will be B max cosine of omega t plus 120 degree, that will be its field along this direction, and cosine of this angle, which is the difference between theta and 120 degree. I am sorry. So, this will be B resultant field at point P, and this thing. So, B resultant at point P will be B max, you can take common 2, and then this is will be 2 cos A cos B. Last time similar things we did, 2 cos A cos B. So, this can be written as cosine. I think I take a new space will not be available. So, B resultant at point P B resultant at point P will be B max by 2, and then 2 cos A cos B is cosine A plus B plus cosine A minus B, the first term, this term. Similarly, the second term will give you plus cos A plus B. So, this will once again give you cosine theta plus omega t, 120 cancels out when you add, plus cosine of cosine of A minus B. So, that will be theta minus omega t, cosine of omega t minus theta minus 240 degree. And finally, the last term will be once again cosine theta plus omega t, these two terms if you combine, and this will be plus cosine of A plus B, that is omega t plus theta plus 240 degree. So, A minus B, the second term was minus 120 minus 120 minus 240, and here it is plus 120 minus minus 120. So, that will be plus 240, and this will be the situation. So, this will be the thing omega t minus theta minus 240. Now, these terms if you look at, this is theta minus omega t is same as omega t minus theta, the first term. So, these three will always add up to 0, because they are phase displaced by 240 degree, means 120 degree. You can add 360 degree here and you can subtract 360 degree here. So, let me write that B max by 2, this 3 of course will be 3 cosine omega t plus theta, and these things will be cosine omega t minus theta plus cosine omega t minus theta. It means that it is plus 120 degree. You add just 360 degree. Similarly, this one plus cosine omega t minus theta, you subtract 360 degree. Adding 360 degree does not change the value to any trigonometric functions. Therefore, it is omega t minus theta and this is minus 120 degree. So, it is like adding 3 sinusoidal or harmonically varying things with 120 degree phase displacement with same amplitude, so 1. So, this will vanish to 0 and you will be left with 3 by 2 B max cosine omega t plus theta. Okay, B resultant at P. Now, so we get a plus sign here. What does this mean? It means it is a rotating field, but moving in the negative direction of theta. Okay. At theta equal to 0 it was here, and it will be moving. So, it is a rotating field moving in the negative direction of theta. And it has to be, because if the rotating field is somewhere here now, after time t, after certain time with respect to theta, it will be leading this voltage. So, it will move if theta is this direction and this is your resultant field here at omega t equal to 0, omega t equal to 0. Then at omega t certain value, it will be cosine theta plus that value, which is nothing but a leading waveform. So, this is theta, and this waveform will then move in this direction. If theta comes out to be negative, it indicates that it is moving in the forward direction of theta. We will see the same thing in a further nice way. Okay, this is mathematically it is all fine. So, as time will pass, if this is the current, at any time if the field resultant field was here, see I am now talking about resultant field at any point at a given time, it is suppose positioned here. So, what I am telling, this is the direction of theta measurement, after some time that field will move like this, that is what I want to tell. Let us see it much more nicely from this diagram. See, suppose this is your R phase coil. This is your Y phase coil, this is your B phase coil. So, R 1, R 2, Y 1, Y 2 and B 1, B 2, and these three I have connected in star and the same diagram. Okay. And I have assumed that I r is equal to I max cosine omega t, these are the current, I y is equal to I max cosine omega t minus 120 degree, phase sequence is r by b, and I b is equal to I max cosine omega t plus 120 degree. And what are these? These are the instantaneous value of the current I r, I y and I b. Now, what I will do is this, suppose I want to see what happens at omega t equal to 0, and I will find out the resultant field for that instant. So, okay. So, if omega t equal to 0, under this condition I r is equal to I max, I y will be I max cosine minus 120 degree, and that will be minus I max by 2, and I b also minus I max by 2. That is, you simply put omega t equal to 0 in this current expressions, you get that. And then sketch, take a snapshot at omega t equal to 0 and figure out what are the field produced by R, Y and B phase. R phase will always produce field along its axis, Y phase this way, B phase this way. Since I r is I max, and I told you if for maximum current the field produced here is B max. So, R phase will produce a maximum field there, and I r is a positive number, it is really entering, and if current enters through R 1, field is away, that is what I have assumed. So, it is like this. But look at the currents of Y phase and B phase. Y phase and B phase currents are negative, that means I b is negative, means current is coming out from this. Therefore, magnetic field produced by B 2 B 1 will be here, and for Y it will be there along the axis of Y, but the current is negative, that means current is leaving Y 1. So, the direction of the field will reverse. So, these are the three fields, and what will be the strength of this field? For I max it is B max, therefore, it will be B max by 2, and this will be also B max by 2. So, the resultant, and these angles are 60 degree. mind you, this is all electrical thing we are doing over a pair of poles. So, this is B max and 60 degree. Because of y phase, it is B max by 2, and for B phase it is B max by 2. Therefore, what will be the resultant field? The vertical component, you have to add these 3 vectors. So, vertical component will cancel out. So, B resultant at omega t equal to 0 is nothing but B max plus B max by 2 cos 60 degree. Is not, this angle is 60 degree. So, B max by 2 plus B max cos 60 degree. What is cos 60 degree? Cos 60 degrees half. So, did I do any mistake here? So, this value is B max by 2, this is B max by 2 and then 2 into this, because the projection of this here and projection of this plus this projection, this projection. So, this will be then these 2 cancels and you will be left with 3 by 2 by B max, and that is expected. Resultant field, no matter at what time you are calculating, it must become 3 by 2 B max. That is what we have found out earlier. 3 by 2 B max is the amplitude of the rotating field. Therefore, it will be 3 by 2 B max. Now, let us consider on the same diagram another instant. For example, so resultant field at omega t equal to 0 is horizontal of amplitude 3 by 2 B max. Effects of that instantaneous current at omega t equal to 0, B, C. Consider another instant. I will do this on this same paper, so that we understand. Suppose omega t is equal to 30 degree. Time passes such that omega t becomes 30 degree. So, if omega t becomes 30 degree, then the value of I r, first we calculate from this I max cos 30 degree. Cos 30 degree is root 3 by 2. So, it will be root 3 by 2 I max. I y it will be, if you substitute 30 degree here, it will be cosine 90 degree, okay, cosine minus 90 degree. So, I y will be 0 at that time, and I b will be I max cosine of 150 degree. What is this value? Minus so, this also, you know, the instantaneous sum of the currents at any instant is 0. So, if this is root 3 by 2 I max, I y is 0, I b has to be minus this one. Anyway, this is the thing. Now, this currents, now current in R phase is root 3 by 2 I max plus it is. Therefore, R phase at omega t is equal to 30 degree, time passes, B R phase field will be horizontal and away from the center, because current is really positive and entering through R 1, and its value is root 3 by 2 I max. So, this strength of this field will be root 3 by 2 into B max, because we have already assumed for I max current B max is produced. So, this will be the R phase field. Y phase there is no field, because I y is 0, no field along this line, but B phase will produce a field. Okay? Because B phase is carrying a current of minus root 3 by 2 into I max. But should I draw the field this way? No, because the current is I B is negative, means current is leaving B, it is flowing exactly at omega t equal to 30 degree. This is the exact direction of the current, and exact direction of the current defines in which direction you should plot the field, is not. If current reverses, then the pole produced will be reversed. Therefore, the axis of y is like this 120, but field produced by the y at this is 120 degree, mind you. This is axis of y. So, this field will be like this at omega t equal to 30 degree. So, this is R phase, Y phase nothing is there, Y phase nothing is there, and B phase, it is B phase, sorry, B phase axis. B phase will have 120, and this field is negative of that. So, root 3 by 2 B max. I have shown the correct direction, that is why positive sign. So, we will continue with this. Thank you.